right, now we're told that we have a wedge with a horizontal plane, ABCD. So ABCD is my horizontal plane, perpendicular to vertical plane, ABFE. So we know that there's right angles where these things attach to each other, because perpendicular means right angles. And then it's given us the measurements that are labeled. So find the length of DE. Well, DE is on this front triangle. So I can see that with that front triangle, I've got something like this, and I've got E, A, D, 10, 4. This is the one we don't know, but of course Pythagorean theorem tells us that DE squared is 10 squared plus 4 squared. So DE squared is 100 plus 16. So DE is equal the square root of 116, which is approximately something bigger than 10 and smaller than 11. So let's see, square root 116, 10.8 centimeters. Now we have some units. All right, the angle between DE and the plane. Well, now we're looking for this angle. Again, I could use any of my SOHCAHTOA, but I'm going to go with tan because I love those numbers 4 and 10. So D is tan inverse of 4 over 10, which is about 21.8 degrees. All right, the length FD. Now this is the diagonal across the top of my wedge, but this wedge is made with a rectangle. So I'm going to draw that rectangle, CDFE. So CD CDFE. So we just found that DE, here's what we just found. I think I labeled this wrong. CDEF. Okay. Let me get rid of that. All right. So always checking to make sure we've labeled things correctly. CDEF. DE was square root of 116. We know that CD is the same as FE, which is 5. We want to find FD. So here's what we want to find. So that's our x. So again, Pythagorean theorem. I can say that x squared equals 5 squared plus square root 116 squared. Of course, squaring a square root cancels it out. So x squared is going to be 25 plus 116. And I can always just put the whole thing in my calculator. 5 squared plus square root 116 squared. And I get 141. So x is exactly equal to square root of 141, or approximately equal to square root, go up and choose it, 11.9. And we had units, so I'm going to call those centimeters. All right. Now we want the angle between the line FD, so my line FD that we just found, and the plane. So if I want to find FD and the plane, I want to make a right triangle. I can come down from B and then connect that way. So now I'm looking at triangle FBD. So let's draw this. We've got triangle FBD. We know this side was 4. We know FD. FD was our x value, so that's root 141. BD, we don't actually know, but we don't care about BD because we're just trying to find this angle, so we want that angle D. So here's what we want, that we could call theta. I've got an opposite and my hypotenuse, so I'm going to use sine is 4 over root 141. So theta is sine inverse of 4 over root 141. So let's see, I'm going to put this in my calculator. Sine inverse of 4 divided by, and I'm going to hit up twice to take my root 141. 19.7 degrees is my approximate answer.